By the end of this video, you'll be able to explain what a system of nonlinear equations is, and you'll be able to explain what the solution to a system of nonlinear equations represents. So let's begin by defining a couple of terms. The first term we want to define is system of equations. And a system of equations is two or more, so you could have, 3, 4, 5, 6, etc., equations that have the same variables. And so it doesn't matter what these variables are, but it contains some of the same variables. And a nonlinear system of equations is a system, but it's when a system has one or more equations that are nonlinear. So it's a very, very specific type of system, and it contains at least one equation that is nonlinear. Now you might be asking, what's the difference between a linear and a nonlinear? So linear, something to keep in mind, is that linear is the most basic type of equation that you're going to see. So that's something in the form that can be written in the form, I guess, of y equals mx plus b. So you'll notice that there's no exponents, there's no square roots, there's no x in a denominator, nothing. It's just the most basic equation that contains a y and an x and some constants and coefficients maybe. Something that is nonlinear will typically contain things like an x squared, or a 5 to the power of x, or a square root of x, or something else. It contains an additional function in there, and that is going to produce a graph that is not a line. So a nonlinear equation is anything that doesn't produce a line. A linear equation is something that can be written in the form y equals mx plus b, and it essentially represents a line. So what we'll be focusing on here is we'll have some linear equations, but every single system that we solve is going to contain at least one nonlinear equation. Now, before we start to solve systems of nonlinear equations, what we need to know is we need to know what the solution to a system of nonlinear equations represents. And if you look at the graph, there's a couple of key points on here that show some relationships between the two functions that you see. So you can see that you have a nonlinear function here in red, you have a linear function here in blue, and what the solution to our system represents is it represents these 2 points of intersection. So when we're solving a system, what we're looking for are the points of intersection. So the solution is the point or the points, depending on the problem, where the two equations intersect. So in this particular problem, the 2 points of intersection are where x is 2, y is -3, and where x is 5 and y is 0. So these are our two solutions to this system because they're the 2 points where the two equations intersect. Now the systems that we're going to solve are going to have a couple of different possible number of solutions. So if you look here, you'll notice that these two equations, as well as these two equations, never actually cross. And remember, a solution is the point of intersection. So there are going to be times when we have no solution because there's no point where those two equations intersect. So be on the lookout for situations where there is no solution. You may also get a situation where there's only one solution. So you can see here that the way that these equations kind of connect, there's only one point where they actually cross. And then you'll also see situations where there are two solutions. You'll see here that having at least one parabola in the problem typically results in two solutions resulting because of the way that it curves up and then goes back down. So as we solve systems that have nonlinear equations in them, we could possibly see a situation with no solution, one solution, or two solutions.